our third semester final grade in all subjects with a group consisting of 4 members. The following are the data we collected, including the scores given to us. After collecting the raw data, we arrange it into an array data. Array is a group of numbers in the rows and columns with the smallest at the beginning to the largest number at the end. The following are the array data. After getting the array of data, we will create stem and log plots. To create stem and leaf, the first step we will to determine the smallest to the largest number in data. For any numbers in the left of the right is the stem, while the leaf goes right from the stem value. After identifying the stem and the leaf, create a table with 2 columns. The first or left column is the stem, while the right column is the leaf.
For example, from the table, the stem is 6 while the leaf is 8. Therefore, the number is 68. Same with the stem 7 and leaf is 0 and the number is 70, and so on. After making the stem and leaf plot, we will now proceed to create a frequency distribution to be able to make frequency table within the range, class size, and class interval. To get the range, we need to subtract the highest score to the lowest score of the array data, or HS minus LS equal R. In our data, the highest score is 96 while the lowest score is 68. R is equal to 96 minus 68 equals 28. Our range is equal to 28. The next step is to get the class size. Use the Sturgis rule to determine the number of classes, and in a frequency distribution with total frequency n, where k is equal to class size and the n is equal to total frequency of the array data. In our data, k is equal to 1 plus 3.322 log n. K is equal to 1 plus 3.322 log 45. K is equal to 1 plus 5.49. K is equal to 6, where is 6 is the class size. And lastly is to get the class interval to proceed in a frequency distribution table. Class interval is obtained by getting the equation of the range and the class size. In our data, I is equal to R over K. I is equal to 28 over 6. I is equal to 5, where 5 is the class interval. We can now proceed to frequency distribution table.
Let's first define what is frequency distribution. Frequency distribution is the organization of data in tabular form, using mutually exclusive classes showing the number of observations in each. K equals 6, or there are 6 classes, count the cell vertically into 6. Our interval is 5, starting from the bottom class, and make 5 counts starting from the lowest score. Since the lowest number in our data is 68, we will start to count from 68 until the count of 5. 68, 69, 70, 71, 72. The left number, or the 68, is the lower limit, while 72 is the upper limit. To get the next lower and upper limit, just add 5. From 73 to 77, from 78, from 82, from 83 to 87, from 88 to 92, and lastly, from 93 to 97. As you can see, there are 5 counts between the numbers. Repeat counting until you reach where the highest score belongs. The highest score in our data is 96, so we stop at 97. As you can see in our data, there are 6 cells, rows, vertically in classes. Since our class size is equal to 6, in each cell, there are 5 counts. The numbers because the class interval in our data is equal to 5. Next is tallying. Look to the stem and loaf to easily see how many scores fall within the classes. From the data, from the score 68 to 72, the number occur 5 times, so the frequency is 5. From 73 to 77 occur 4 times, and the frequency is 4. From 78 to 82 occur 5 times, and the frequency is 5. From 83 and to 87 occur 9 times, and the frequency is 9. From 88 to 92, the tally frequency is 12. From 93 to 87, the tally and frequency is 10. Class boundaries. To get the class mark, you need to get the average of the lower and upper limit. Add the lower and upper limit, then divided it to 2. 68 plus 72 divided by 2 is equal to 70. The class mark of class 68 to 72 is 70. Repeat the process. 73 plus 77 divided by 2 is equal to 75. 78 plus 82 divided by 2 is equal to 80. 83 plus 87 is equal to 85. 88 plus 92 divided by 2 is equal to 90. 93 plus 97 divided by 2 is equal to 95. To get the less than class boundaries, subtract the lower limits into 0.5. 68 minus 0.5 equals to 67.5. 67.5 is the less than class boundaries. To get the highest class boundaries, add the upper limit to 0.5. 72 plus 0.5 equals to 72.5, and so on. Cumulative frequencies. To get the less than cumulative frequencies of the following classes, start with the frequency of the lowest class. At the frequency of the lowest to the highest class, start with 5 and then add 5 to the next frequency. 5 plus 4, 9, 9 plus 5, 14, 14 plus 9, 23, 23 plus 12, 35, and 35 plus 10, 45. To get the higher than cumulative frequencies of the following classes, start with the frequency of the highest class. 10 and likewise. 10 plus 12 equals 22, and so on. The highest value of cumulative frequency should be equal to the total number of frequency, and 45. Relative frequency and percent relative frequency. To get the relative frequency, divide the frequency of each class by the total number of frequencies to obtain the relative frequency. 5 divided by 45 is equal to 0.11. 4 divided by 45 is equal to 0.0889, and so on. To get the percent relative frequency, multiply relative frequency to 100. 0.111 multiplied by 100 is equal to 11.11%. 0.0889 multiplied by 100 is equal to 8.89%.